So from this video, we are going to start a new kind of machine learning problems that is called as the classification. And in this small video, what I will be doing is that I will be defining the problem of classification in the context of what we have studied so far. So we have covered the topic of regression so far, and here I am defining the classification in the context of regression analysis, and we are going to define the problem of classification and by defining how it is differ from the problem of regression. And we have seen that in case of the regression analysis or in case of the regression modeling, our objective is to establish a relationship or a function in between the independent variable and dependent variable. And most of the time, we assume that the relationship between the independent variable and the dependent variable is a linear one, and we define the for multiple linear regression the relationship is like this: beta 0 plus beta 1 times x1 plus beta 2 times x2 plus beta 3 times x3 up to the beta n times xn. And the purpose of regression modeling is to define the parameters like beta 1 beta 2 up to the beta n. And we have seen different types of algorithms to estimate the parameters of beta 0 to beta n. And while discussing the multiple linear regression or the regression problems in general, we saw that the input variables, that is x1, x2, x3, xn, or the independent variables, are of two types. One is called as the numeric type and another is type is called as the non-numeric or qualitative types. And when there is the qualitative type of variables are there, we have seen there are different methods are there which convert the non-numeric data into the numeric data. We have seen the different methods for encoding non-numeric data into the numeric data so that a linear regression algorithm can process that kind of data. So that was the about regression analysis. And in the context of regression analysis, the classification problems are defined like this: when the values of the y are non-numeric, that kind of problems are called as the classification problems. Like the regression problem, the classification is the task which establishes a relationship between the independent variable and the dependent variable, provided that the dependent variable is the non-numeric type. In case of the regression analysis, the dependent variable is always the numeric type. So here, for example, the regression analysis, the dependent variable or the output variable is always numeric type, and it is never discrete or categorical type. In case of the classification problem, dependent variable or output variables are always discrete or categorical one, and they are never the numeric type for the example for the case of classification. And in case of the regression, the independent variables or the input variables may be numeric or non-numeric. And similarly, in case of the classification problem, the independent variables or the input variables may be numeric or the non-numeric. In case of the independent variable, there is no much difference between the regression and the classification problem. But in case of the output variable, there is a major difference between the classification and the regression is that for the types of classification, the output variables are always qualitative, non-quantitative, or discrete variables. Here are few examples of classification problem. The first example is classifying a student, whether it is the employable one or the unemployable one. Here these are the output variables, and it takes the value employable one and the non-employable one. And the input variable may be the CGPA. From the CGPA, I would like to predict whether the student is employable or the non-employable one. Here, what does it mean by employable one? A student is able to get a job by the end of 8th semester, either through campus recruitment or off-campus drive. That student is, I am calling it as the employable student. Other students, I am calling it as the non-employable one. And here one of the criteria that I am going to use is the cumulative grading point average of a student. Another example, see here, another example is classifying persons, whether the person is obese or the non-obese one. Obese means the student, a particular person is very fat, and the non-obese means a particular person is slim or thin or healthy. So classifying student, here you can use one of the criteria as the weight. Here the output or the dependent variable is the obesity, is the dependent variable, and the weight is the input variable. The third type of the problem is called as the whether a particular tumor means the swelling or the outgrown part of in our body, so on a particular organ. So to whether the tumor is malign means danger, or the non-malign, whether these are cancerous one or the non-cancerous one. So that can be decided by considering the size of the swelling or the size of the tumor. So if you observe here that output variables are always taking the values 2, that is either employable one or the unemployable one, obese or the non-obese, malign or the non-malign one. Such kinds of problems are called as the binary classification problem. In the binary classification problem, the output variable takes only two values, that is either means employable one or non-employable one, obese or the non-obese one. Now there is another kind of problems are there, which we are calling it as the multi-class problem. In case of the multi-class problem, the number of the output values for the output variables are more than two. Like for example, Google Mail, Gmail classifies the mails that you received in different categories. Like your mail may be primary one. If you receive a particular mail from a social networking site like Facebook, Quora, LinkedIn, then those mails are classified into the social sites. If the mail you received from certain suppose that you have purchased some item on the Amazon sites, the status of the order is updated. Then that kinds of mails are classified into the update group folder. Then sometimes you may be the members of some society. So mails that you receive from those groups are classified as a forums. Sometimes you receive the mails as a advertisement. So those advertisements of the products. So those mails are classified under the category called promotions. So here there are more than one output values are present: primary, social, update, forums, and promotions, which are the five numbers. So when the here the things that you should note down is here, that here I am going to introduce one more term called the classification category. The classification category by means classification category. The classification categories are the values that a particular output variable takes. Here the employment one and the employable one and the unemployable are the classification category. In the second task, obese and the non-obese are the classification category. For the third task, malign and the non-malign are the classification category. For the fourth one, the primary, social, update, forums, and promotion are the classification category. Binary classification takes only two classification categories, and in case of the multi-class classification, there are more than two classification categories are present. So in reality, as compared to the regression problems, there are many situations are classification situations, and we need to know which kinds of classification algorithms we are going to use. So we have seen that if whenever there is a non-numeric type of variable is present, then those non-numeric variables can be converted into the numeric category by encoding. And one of the simple approaches to use that conversion, and let us use the linear regression. But this strategy fails most of the time, and there are three different reasons or three situations where such strategy fails. Presence of outliers. Second is the linear regression may output a value greater than 1, and different models for the different encoding. Let us consider again the problem of classifying whether a particular person is obese or non-obese based upon the weight. And here the weight is taken on the x-axis. That is, and it's normally take the values in between 10 to suppose 150. And obese takes two values, obese and the non-obese. And we are non-obese, we are taking it as 0, and 1 means that it is the obese. And we can plot a regression plot like this, and we can check whether the particular value is greater than the zero point 0.5. Then we can convert, suppose that this value is zero point 0.6, then this get a zero point 0.5, then that person which we can classify it as the obese one. So if the obesity value is greater than 0 point, that person is called as the obese. Otherwise, it is not obese. So, like for example, this particular case. But sometimes what will happen that there are some persons in the data set, if the outliers are present. Now, in this case, there are no outliers are present. But suppose that there is one person whose weight is 115. In order to accommodate this data observation, we need to replot our regression line like this. Now we have taken the criteria that zero point 0.5 value is, we are taking it as the mid value, and whatever the value weights that are associated with the zero point 0.5 and greater than that, all are obese. Now here the weight is taken as 100, and we are classifying that the a person is having a weight greater than 100, then those persons are obese. But in our data set, there are very few such data samples are present, and it has reduced the criteria of obesity, which is very wrong. And this has happened because of this one particular outlier. Outliers are those observations which greatly vary from our average value. So we have seen what does it mean by the outlier, and in this particular case, this outlier, that is 150, we have replotted a graph, and we got a very different linear regression line in that this as compared to this. This model used to predict the classify the models, but this product is wrongly classifying the models, and this is due to the presence of the outliers. The second reason why the linear regression model is not used is the it may output value greater than 1. Now see, while adopting the linear regression model, we have think that 0 is non-obese and 1 is obese. And in this in this particular case of 150, the value that is associated with the output is greater than 1. So that is the 1 point something in between the 1 and 2. But in this particular case, value should not exceed between the 1 0. The values of the output should always be between 0 and 1. But here it is exceeding. So this is a wrong way of predicting the value. So that's why again the linear regression is not used. The third reason why the linear regression is not used in for classification is that different models, you will get the different models when you use a different encoding. Now let us consider the task of predicting climate based upon the humidity level. And you can use this linear regression model, simple linear regression equation like this. The humidity level takes the four values: clear, cloudy, hazy, and rainy. And suppose that this is one particular encoding scheme, encoding 1, in which you have used 0 value for the clear, 1 value for the cloudy, 2 value for the hazy, and 3 value for the rainy, you while converting in the numeric format. And second encoding is that uh, you have used the clear for 3 for clear, 2 for cloudy, hazy, 1 for hazy, and 0 for the rainy. So these two values are very different kinds of encoding, and you will get different kinds of uh, models, because and both, even though the data set is the same, you will get the different reading. Because why it is happening? Because it is considering a natural order in case of the numeric numbers, like 0 is less than 1, 1 is less than 2, 2 is less than 3. But in this case particular, means that clear is less than cloudy. This interpretation is wrong. Cloudy is less than hazy, and rainy is hazy is less than rainy. This interpretation is wrong. But while building the numeric processing the data, many linear regression of the algorithms assumes that such natural numeric order is present whenever the data is numeric type, which is wrong, and that's why we get a very different kinds of results. So that's why we are not going to use the linear regression algorithm. The fourth and the most technical reason is that we have seen while discussing the linear regression algorithm, that the residual error, that is the difference between the actual value and the predicted value, we are calling it as the error. So if you plot the residual error graph with the actual values, then you should get the distribution like this, which is called as the normal distribution. But in this particular classification problem, the output values always take the 0 and the 1. The predicted value is also belongs to normally in the range between 0 and 1. So you will not get the such kinds of normal distribution in case of the classification problem, and that's why we are not going to use the linear regression problem, linear regression method to solve the classification problem. So these are the four reasons why a simple linear regression technique fails to classify the classification problem. Thank you.